All right, so we're going to talk about regular polygons, and so just to remind you what a regular polygon is, okay, we have the definition up top. It says a polygon that is regular is both equilateral and equiangular. So to dig into that a little bit more, we said equilateral means that all of the sides are equal in length, and equiangular means that all of the angles are equal in measure. So we have lots of equality going on inside regular polygons. So all the sides are equal, all the angles are equal. Okay, so we're going to define a few words that we're going to apply to regular polygons, and we're going to use some of this information to help us to find the area of a regular polygon. Okay, so the first one is a radius of a polygon. Okay, and so we've heard this word radius before when we're talking about circles, and so a radius is defined in a polygon as going from the center of the polygon to any vertex of the polygon. So just like in a circle, how there are multiple different radius depending on which direction you draw, the same thing happens in a polygon. Depending on which direction, which angle you go to, you can have a bunch of different radius lines, which we're going to illustrate all of this stuff again. Okay, so an apothem is a different type of line, also coming out of the center of the circle, but instead it's going to a middle of a side instead of going to an angle, right? So if you take a look at our picture over here, which again, we'll highlight this a little bit more in a separate example, okay, we can see that we have a couple of radius lines drawn here, right? So these two lines right here, going from this center point P, right, out to M, right? That's at an angle for this hexagon, right? And then if I go from P out to N, right, there's a different radius line, and there are actually also other radius lines, right? We could actually go to any of the other sides. Ooh, I'm grabbing a highlighter. Let's fix that. Okay, so I could actually go right in this direction, and that's a different radius line, and this is a different, right? So we have tons of radius lines that we could draw. Okay, and then the apothem is different because instead of it going to that side, right, it's going to go from instead of it going to an angle like M, it's going to go to the middle of the side MN at a right angle, right? So we go from P to Q, which is the middle, it's the midpoint of MN, okay, and we're creating a right angle, right? So it's actually an altitude, right, instead of just being a median. Okay, so apothem, radius, two important line segments. We're going to see both of those as we do our examples. Okay, so the last thing that we're going to talk about, we'll talk about this last statement in our example. Okay, a central angle is created by drawing two radius lines that are right next to each other and then measuring the angle in between them. So again, if you take a look at this picture here, if I draw from P down to this vertex, I could pick either of the vertex lines that are right next to the one that I drew to. So for example, I could maybe come over here, okay? And when I drew from P to two consecutive lines, I created an angle, right here in the center, and that is a central angle. So again, because this is a hexagon, I'm going to have 6 different central angles because I could talk about any two consecutive radius lines, right? So we have a lot of like vocabulary here that we have to go through. So I want to start off a fresh example and just have you see again, these vocabulary words, right? So I have a blank screen, and we're going to pick let's go with just a simple pentagon, right? So this is a regular pentagon, okay? And in the center of this, okay, we'll roughly say is about here, okay? We have the center, okay? So from the center, I can actually draw lines from here to every vertex, and just pretend like my lines are nice and straight and even, okay? So I can go to any of these vertex lines, and every single line that I'm drawing right now is a radius, okay? So a radius is from the center to any vertex. So I just drew 5 radius lines, okay? In between any of these two radius lines, okay, I have a central angle. So each of these angles that are in between two radius lines are central angles, and all of those central angles are equal to each other, right? Because they're all across from equal sides. So we can actually say each of these 5 angles that I just drew an arrow through are equal in length. And I just made a circle, and a circle's got 360 degrees. So I can actually say even more definitively that each of these angles that I just created is 360 degrees total, divided by 5 of them, right? And so that looks like, I believe it's going to be 120, well, let's just do it. 360 divided by 5, okay? 72 degrees, okay? So we're going to say 72 degrees each. I know every single one of these angles is 360 divided by 5, which is 72 degrees all the way around. Each of these is worth 72, okay? So I can gather some information about the central angle. We know there are 5 of them. We know there's 360 degrees total. Each one's got to be worth 72 degrees in this particular example, okay? So I'm going to get rid of this bottom 72 degrees because we're going to actually do some more with it, okay? So I'm going to get rid of this one. And so now what I can do is this triangle that I just created, which we know has 72 degrees at the top, okay, I can go a little bit further and say, okay, that if I draw from the center straight down to one of the edges, right, so I just picked this bottom one, okay, I just created a right angle, right, so I'm going to put a right angle here, okay, and I know that this 72 degrees that was in this space just got split up into two equal 36 degree angles, right? So now I know that this is 36, which means the one down here has to be 54 because I have a right angle of 90, right? So we just created a right triangle, right? And so that's helpful for us. We know a lot about right triangles, right? So if you're going to do this, you need to know about 30, 60, 90, 45, 45, 90, Pythagorean theorem, sine, cosine, tangent, all of those right triangle related calculations that we can do. We're going to use those to help us when we're finding the area of a regular polygon, right? So we're just going to do one example where we're going to take a look at a picture of some of these regular polygons, knowing a radius, knowing an apothem, what they do, right? We're going to try to figure out just some angle measurements because you're going to see this is helpful in a little bit, okay? So in each of these examples, I'm looking at this one and I'm seeing 1, 2, 3, 4, 5, 6, 7, 8 sides, right? So I'd call this an octagon, okay? It's got 8 sides, okay? And so they're asking me about the measures of angle 1, angle 2, and angle 3. So angle 1, which I'm going to again just highlight for us so we can see where it's what it's being made of, okay? Angle 1 is going from the center to an angle and from the center to an angle. It is surrounded by 2 radius lines, which means it's a central angle. So to find the measure of angle 1, I'm going to say angle 1 is actually 360 divided by 8, and it's divided by 8 because there are 8 central angles in this picture, right? So 360 divided by 8 means that each of these angles is worth 45 degrees. So I can say that this angle 1 is 45 degrees, okay? Angle 2 is made by taking this central angle here between 2 radius lines and then drawing in an apothem, right? So let me just highlight the apothem. This line right here is the apothem, okay? So I just cut a 45 degree angle in half, which means that angle 2 is going to be half of 45, which is 22.5 degrees, okay? And then to figure out this angle 3, I'm just going to focus on this right triangle here, okay? Oop, I pulled out my crayon tool. That's not right. Okay, if I focus on this right triangle, okay, again, what we know is that this angle is worth 90 and angle 2 is worth 22.5, right? So we can actually say that that last angle, okay, has to be equal to 67.5, right? So this is just the rest of the right angle of the right triangle, which is 67.5 degrees, okay? So any of these shapes, we have the ability to know a whole lot about the angle measurements that are inside of all of these triangles that we create. And if you notice in this picture, I don't know anything about how long any of these sides are. I don't know how long a radius is. I don't know how long an apothem is. I don't know how long any of the sides are. But without knowing any of that, we know that every octagon, every regular octagon, okay, is going to have central angles of 45 degrees. When we draw an apothem, we're going to make 22.5 degree angles, right? And we can even figure out some of the other angles, like angle 3 down bottom, okay? So in the next video, what we're going to actually do is take some of this information, take some of this knowledge, and combine that with all of the trig stuff that you've learned in the past, like sine, cosine, and tangent, or special right triangles, and we're going to use those facts to help us actually find the area of a right triangle, of a regular polygon.